All right, let's start section 2.5. This is where we're going to get into proofs. So we're going to go over some properties that should be familiar from Algebra 1. The first one is the reflexive property. Remember, that has that almost that word reflect in it, so we think like a mirror. So in algebra, you would have seen it A equals A. So same thing equals same thing. That's going to be pretty much the same for geometry, except we might have something like AB segment. AB is congruent to segment AB, or angle A is congruent to angle A. Okay, so that would be a reflexive property of congruence. The next one we have is the symmetric property. Symmetric means you kind of flip it over the equal sign. So in algebra, if A were to equal B, then B equals A. So A was first, and then A was last, okay? So in geometry for segments, you could have if AB equals CD, then CD equals AB. So basically if they switch the order. So if we want to write that, you can put a little note on your notes. Switch the order. Okay? And then, so another example with angles, if the measure of angle 1 equals measure of angle 2, then measure of angle 2 equals measure of angle 1. Next one, the transitive property. How I like to think of the transitive property is transfers information. Okay, so in algebra, if A equals B and B equals C, then A equals C. So we got rid of the middleman, the B's matched, so we take A and C and make a new statement, okay? So geometrically, if AB equals CD and CD equals EF, let's get rid of this middleman because CD is mentioned in both, so AB must be equal to EF as well. Okay, so if we're looking at the pictures, if AB is marked as being congruent to CD, and then I have maybe that CD, so mark it with blue, all right, is congruent to EF. Well, if CD is that same length, then the other ones must be the same as well. All right, the next property, we have addition and subtraction. So for addition, it just basically means if you add something to both sides of an equation. This is going to be mostly used in algebra. Okay, so see right here, they added 4 to both sides of this algebraic equation to solve for x. So that would be your addition property. And then with the subtraction property, they subtracted 9 here from both sides of our equal sign. So that would be the subtraction property. Simple as that. All right, then we have multiplication property. So similarly to addition and subtraction, it means that you would multiply some value on both sides of the equation. So they multiplied these 2's to both sides of the equation so that that will cancel and we get x equals 70. Okay? Then, division property, we have -6 times x. So in algebra, we would divide by a -6, and they did that on both sides of our equal sign here to get x equals -12, so that's the division property. Last two, we've got substitution property. For all numbers, if a equals b, then a can be replaced by b in any expression or equation. Okay, so if it's 7 minus 2 and then times x equals 5x, the 5 is replaced by 7 minus 2 because 7 minus 2 equals 5. So that's one example of a replacement. Another one would be if angle A equals angle B and angle A equals 5 degrees, then we can say angle B equals 5 degrees. We can substitute B in for angle A, okay? And then last one is the distributive property. For all numbers, A times the sum of B plus C, we can write that as AB plus AC. So what happened? We brought the A to each part in our parentheses and multiplied that. So an example algebraically would be right here where we have -3 being multiplied by x, being multiplied by 7, which is represented right here as -3x and a -21. Okay, so the -3 was distributed to both terms. Okay, now let's go ahead and do some proofs with these properties that we now know. So here's an algebraic 2-column proof. We are given that if 3 times x minus 5/3 equals 1, then x equals 2. So a proof we are not solving the problem. The problem is already solved in the statement column of this proof, but we need to put in the reasons. Why can they make these steps when solving? So our first reason is always given. We always put the hypothesis of this conditional statement as our first statement, and the reason is that it is given. Now we look at statement number 2. We have 3 times x minus 3 times 5/3. So it looks like 3 got multiplied to both things inside this parentheses. So that would be the distributive property. All right, just exactly how you would solve it. So we just have to give that reason. Now next, from step 2 to step 3, what have they done? The 3x stayed the same, but now they have a minus 5 instead of 3 times 5/3. So they multiplied out that 3 times 5/3, and they called that the substitution property because those are equivalent values. 3 times 5/3 equals 5, so they can substitute that value in. Now from step 3 to step 4, we have 3x minus 5 plus 5 equals 1 plus 5. Now this plus 5 was what was added to this step. Since we were adding 5, we have the addition property. All right. And next, again, we have that substitution property because minus 5 plus 5 is 0, so I'm left with just a 3x. And then 1 plus 5 became 6, so we substituted the equivalent values in. All right, and then next, we have divided by 3 on both sides of our equation. So we have the division property. And we end up at our answer, x equals 2. And that is by substitution because 6 divided by 3 equals 2. Notice how the last step of my proof matches my conclusion in my conditional statement. So your hypothesis should be your step number 1, and your conclusion should be your last one. We don't know how many steps something might take until we actually solve it out, but that will always be your last statement. All right, let's do another example. So now we actually have to solve this one out. So let's go ahead and do it step by step. So our first statement is always our given or our hypothesis. So we'll just rewrite this. -2 times x plus 7 equals -32, and our reason is always given. Now, the first step I would do in solving this is distributing that -2. So it would become a -2x, and then a -2 times a positive 7 becomes a -14, and it's still equal to -32. Since we distributed, we will call that the distributive property. So the algebra has not changed, we just have to give a reason for what we're doing. All right, now the next step in solving this 2-step equation, I would add 14. Oops, let's go. That's a -14 plus 14 equals -32 plus 14. Because what we do to one side, we do to the other, and we have the addition property. All right, so now let's go ahead and we have -14 plus 14, which will end up canceling out. So we're left with just a -2x on this side equals a -32 plus 14 is a -18, okay? And since we substituted in, we have the substitution property. And then we have step 5. The next step we would do to solve is going to be to divide by a -2. So we need to write out that as a new step that we are dividing by a -2. Since we are dividing, we have the division property. And now let's do that division. Negative 2 divided by negative 2 is 1, so we are left with 1x over here. And negative 18 divided by negative 2 is 9. Okay, by the substitution property. All right, and since we ended at our conclusion of our if-then statement right here, then we are done with this proof. So this one only took 6 steps. All right, let's go to one geometric proof and then we'll be done. All right, so these are called 2-column proofs. That's what we've been doing on the front and right here. So we are given that the measure of angle 1 equals the measure of angle 3. We talk about pictures a lot in geometry, so we are going to use this picture. All right, so let's draw our congruency markings in. Measure of angle 1 equals the measure of angle 3. Now, in blue, I'm going to put what we want to get to, just so we can start getting some ideas of how we might want to do this. All right, so I want to get that the measure of angle AEC is congruent, 2 marks, to DEB. So I want it congruent to that angle there. So let's go ahead and go through this proof and see what we can do. So measure of angle 1 equals measure of angle 3 is given because that is always our first step. In this case, it just gave us given. It didn't put it in an if-then statement, and that is okay. Notice what we have to prove is our last statement of this proof. Now, we have the measure of angle 2 equals the measure of angle 2 by the reflexive property, because same thing equals same thing. All right, and because we're talking about this angle right here, and we need to include that in what we're working towards, so we need to involve it in the problem. All right, now we've got the measure of angle 1 plus the measure of angle 2 equals measure of angle 3 plus measure of angle 2. This would be the addition property. Even though it's not numbers like we're used to with algebra, we went ahead and added the same thing to both sides of our equation here. We added the measure of angle 2. Now we've got the measure of angle 1 plus measure of angle 2 equals the measure of angle AEC. Looking at our picture, here is 1, here is 2, and that makes up our whole AEC angle. All right? And then the next one says that measure of angle 3 plus measure of angle 2 equals the measure of DEB. So the measure of angle 3, measure of angle 2 equals DEB. Okay, and that's just our part plus part is whole. And what that will be called, how you should refer to it in proofs is this as the angle addition postulate. Okay, but that's your part plus part is whole. And then we are left with the measure of angle AEC equals the measure of DEB by substitution. And this is by substitution because if we go ahead and look at statement number 3 here, measure of angle 1 plus measure of angle 2, and that is right here. And then we have measure of angle 3 plus measure of angle 2, measure of angle 3 plus measure of angle 2. We called those things equal right here. So then if these two things are equal, and those are equal to these, we can substitute it in to say that the measure of angle AEC is equal to the measure of angle DEB. And that'll conclude our 2-5 notes. We'll do a lot of practice with these proofs when we get back into class.